Hey, thanks, Joe. That was really helpful. You won't get much time to catch your breath before moving on to the next. We just have a few minutes for questions, but I wanted to share again the foundational importance of this valley bottom exercise. I think you always do a great job of distilling geomorphology down in a way that normal human beings can understand. And so we've made this a big part of the workshops over the years because it's really important for you to be able to read the landscape, in particular understanding that valley bottom. Think about the relevance to riparian planting. You know, how often do we see riparian plants planted in the wrong place in the valley bottom that will never be wet, or perhaps they'll be too wet. So this could be an important tool for you for lots of different restoration. I wanted to summarize a couple of questions related to fans and this idea of fans being confining. A couple of folks asked, you know, like, aren't they typically highly erodible, or could that depend on the actual type of material in the fan? Do you have any comments on that and why it would be considered confining?
Well, Jeremy, you know better than to ask a gym.
I know, and you have 30 seconds.
Okay,
Yeah,
30 seconds. How much energy, how much stream power, discharge times slope does that system have that's nibbling into it relative to the caliber of it? So if you're coming from a really steep drainage that has really big coarse material and coming into a little valley that has a wimpy little stream, yeah, it may just it's going to certainly not going to be able to erode that as much as, let's say, something that's a real low angle fan, fine grained material, and a really energetic system. It could eat away at that, but it's still, at that snapshot in time, when you do the map, an active confining margin, and it is, depending on how regularly it pukes out, it's controlling the position of the channel on the valley bottom and probably constricting that valley bottom.
that was very efficient for a geomorphologist. Nice work.
That was hard for me.
Yeah, I know. You're really holding back. So one thing I wanted to add on to this that we talk about when we're out in the field together, you know, I come from what was at one time the Soil Conservation Service. It's in our DNA to stop erosion. Our idea of stream restoration has typically been equivalent to bank protection in many cases across the country. And we're trying to help landowners protect property that is eroding away, and we've taught them to fear erosion. But one thing that I see with this, the tools you've just given us, wow, you know, now I can have a conversation about, well, what feature is actually being eroded here? You know, if it's a fan that is constantly having material added to it and that you're just eating away at the fan and that material, if I can explain to a producer that that's not, if you don't have a corral or, you know, irrigated crops sitting on that fan, that's just taking material from that upland and putting it into a floodplain where it can be more productive. That's a conversation I'd like to have. And do you want to add anything from your perspective, that whole conversation, the whole paradigm of erosion being bad and how this information can help us?
Yeah, I don't know if I've ever confessed to you that once upon a time I was a certified professional in erosion and sediment control. And
How
yeah,
dare you?
the whole thing was, you know, erosion bad. Yes, it's analogous to fire being bad, right? Sure, some types of fire, too much fire, anthropogenically accelerated intensity of fire. Of course, those things can be bad. And it's a little bit of a confusing message. But just like with fire, we've learned that actually that natural fire regime and having some fire is a hallmark of a healthy system. If it burns more regularly and less catastrophically, that's a good thing. The irony with erosion control, especially along rivers, is, you know, if you are preventing the erosion, sometimes you can effectively diffuse energy, but a lot of times you're just transferring that energy down somewhere else. And so, you know, maybe it's your problem downstream or your neighbor's problem. But yeah, that would be the analogy I would use.
Great. And then kind of just one last question for you, quick. There's interest in that VBET tool, but I think the question is probably more broadly to the mapping of valley bottoms and whatnot. Is that just for arid environments or semi-arid environments? You know, we're giving all our examples from the West, but could this be used across the US or globally?
It could be used on Mars. So Mars actually has better wall-to-wall topography than we do for the damn planet here. But yeah, it could be used anywhere.
Okay.
It's just you need good topography as an input. Warning, the tool is a research grade tool. It's fragile. If you know what you're doing with GIS, you can make it work. What we're developing right now is a commercial grade tool, which makes it idiot proof to operate. That's probably what most people on this call are going to want. If you want to dork out in the GIS, yes, it's all open source, but that doesn't mean it's easy.
Yeah, and one thing we've always stressed together here is don't get obsessed with the tools first. People want the shiny tool to help them. What we're going to give you is a crayon and a piece of paper to think, and that should be enough to get you by for now, but someday the tools will be where we want them, right?
Yep, the questions are far more important than the tools. We stop thinking when tools are too easy sometimes, so focus on those questions.
Right on. Okay, Joe, time to move on to the next presentation.